Hey guys, we're going to get into circuits today. And circuits being defined as a closed path that electricity flows in. A closed path that electricity flows in. So this is basically us controlling an electric current. So there are two main types of circuits. We're going to look at series and parallel. But the first thing we need to do is look at some schematics. So electricity schematics. So we have, I'm going to write electricity schematics. Electricity schematics. Now, I'm going to give you a list of symbols, and I think most of this will make sense to you guys pretty fast. Most of them are sensible. But I'm going to give you a list of symbols that I want you to know to be able to identify on schematics. So let's start with that. So first of all, it's just a line. That is a wire. So I'm going to pull my phone down here and get a little closer to it here. So this is just a wire. It's just a line. Then you have a power source. So anytime you see that means there's power. All right, and there's going to be a minus here and a plus here. And that is just a generalized symbol that there's power, that there's electricity that can flow through the line. If it's a battery specifically, multiple cells. So like in your car, you have a 6-cell battery. However many sets of short and long lines there are, that's how many cells there are. So for instance, there's a short, long, short, long, short, long. That's 3 sets. This would be a 3-cell battery. So if this was in your car, for instance, most car batteries are going to be 6-cell batteries. So this would be 3 cells. Or like if you were powering a toy for your little brother or little sister and it's got 3 AA batteries, it would be drawn like this. It's 3 cells, 3 batteries, or 3 parts of a battery. All right, so that's cells. All right, the next one is a switch. So this is an open switch or off. And this is a closed switch or on. So, and if you can see that these wires here on the open one are not connected, and so electricity can't flow through there. They have to be touching. So that's open or off. On the bottom one under closed, the electricity is touching from one side to the other, so it's closed or turned on. So if your light's turned off in your bedroom, it's open. If your light's turned on in your bedroom, that's closed. All right. The next one is a light, and there's a few different ways people write this. That's a straight line, and usually it's going to have something like this and a little bulb around it. And so that represents the glass, the globe around the light, and then the little things at the jagged lines in there represent the filament. All right, so that would be a light. All right, and that's probably not super well drawn. More like that. All right, so it's a light. The next one you have is a resistor. Now we haven't talked about resistors yet, but a resistor is going to hold on, my marker's not working for some reason. There we go. All right, so a resistor is going to be like that, and a resistor is going to slow down the flow of electricity. And the point of that, why you'd have a resistor, is that obviously we don't want to put too much electricity into something, or it's going to overheat and burn up, catch on fire, that kind of thing. So a resistor slows down the flow of electricity. All right, the next one is a motor. Anytime you have a motor on a line, there are different, more specific types of motor symbols, but this is a generalized. It's just a circle with an M in it. It's a motor. And then you have voltmeters to measure how many volts are going through something. Volt meter. And then you have an amp meter as well with an A. And those all are the same thing with just different letters. Amp meter. How many amps are going through something? All right. We've got a few more here. So I'm going to close those out and start another set. All right. We also have an outlet. So an outlet. It's an outlet. One side's bigger than the other. We also have a grounding, which we talked about in the last lecture. Grounding, which is going to be connecting it to the earth so it doesn't fry your house. That is grounding. And then the last two things you have are a fuse. You can't hear my children fighting in the background. And then you have a breaker. So let me give you a quick background on the fuse and the breaker. So a fuse and a breaker, you have one or the other in your house. If you have a newer house, you have a breaker box. If you have an old house, you have a fuse box. So a breaker box is the new way to do it. And if you remember when we took a compounding bar in our thermo unit and we heated it up on a Bunsen burner and it bent really bad, right? Because it had two different metals and it bent. All right, so if you can picture something like that sitting inside your breaker box, what happens if too much electricity goes through at once, that metal overheats and it bends and it no longer touches. So if this is one side and my other hand's the other side and this is connecting them and this overheats and it bends, it can no longer touch. And so it's a safety feature that keeps your house from overheating. So if your mom plugs in too many crock pots on Easter or something and the breaker goes off and you have to go out to the garage and flip a switch, that's what's happening. It's a safety feature to keep you safe from the fire starting. And so it's connecting, it overheats, it bends, no longer touching, so power goes off. It's an open switch now. All right, if you have an older house, you have a breaker box. And the breaker box, if you have an older house, you have a fuse box. And the fuse box, what happens is actually something melts inside of that. And so this wire inside of here melts and it's no longer connected. And so what happens is your power then goes off and there's no connection there anymore. All right. So that is it for the symbols. Now, I think I'm going to separate this lecture out. I was going to do it all at once, but we'll do another lecture over the two types of circuits. So just take the notes over the scheme for now, and we'll do a separate one over the types of circuits.